know it's been a while since you've seen my lovely face, so I just wanted to grace you with my presence this morning. I'd also like to talk you through the online prac we're doing. Yes, we're doing a prac online. We're seeing whether things float. Because we're doing it online, like it's only a simulation of real life. If you wanted, you could get an array of objects, like, bucket of water and then see if stuff floats in it. But it would be harder to figure out each object's mass and volume. Although, I might set up a prac that you do at home where we do that. So let's get away from my amazing face. And let's have a look at Year 7B Science Crayons. Okay, we're in class notebook. Once it loads, I do not want desktop notifications. Once it loads, the arrow thing, I'm going to go to content library. You would go to your name. Term 1, and we're on why do things float? Okay. So we're running this whole thing at this website when it loads. So let's have a look. Put myself in the corner, shall I? Oh, I can't make myself small. All right, goodbye again. Okay, I'm assured it will load. Yes, here we are. So, first of all, you're going to look up each of these things and write the definition. So for example, buoyancy definition. Let's have a look. The ability of something to float in water or other fluid. The ability or tendency of something to float in water or another fluid. You would go through and you would look up each of those. Now, graduated cylinder is this thing. Just means that you can see what kind of volume of water we're going to start off with, and you can see what it goes up by each time, and that can tell you the volume of an object. It's very handy. Okay, of these ones, circle the ones you think would float in water. You can do this by drawing. You could literally, draw a big red circle around the ones that, well, I don't think a rock would float, but for example, yeah, cruise ship would float. And if you do this on the OneNote, then I can see that you've done it. Let me get rid of mine because why do you think some objects float while others sink? Well, I actually know the answer, but I want you to think, why does some stuff float but other stuff sinks? Like, why would a cruise ship float but a rock sinks? Okay, so we're going to this website? No, we're going to this website. Write the name of the object in the table. So we're starting off with, small coney thing. Small red cone. Its mass. So then I'm going to put it on the scales, and I've discovered that it's 19.5 grams. 19.5 grams. The volume of water displaced, that means that we now put it in the graduated cylinder. Now it started at 400 mil. It's now up to 414 mil, so it displaced 14 mil. It went up by 14 mil, so its volume is 14 mil. Does it float or sink? It sank. It didn't sink right to the bottom, but it still sank. And its density. So here you're going to do 19.5 divided by 14 equals, well, calculator, 19.5 divided by 14. I'm just going to write the 2 decimal places, 1.39 grams per milliliter. And you're going to do that for each of these objects, okay? So let me get my cone out here. Hey. Oh, and here you can play around with it and see what density it would have to be for that thing to float. I'm not expecting you to do that, by the way. Let's put you back on the shelf. And now we've got this one. Flash Player is blocked. It should not be. Why is it blocked? Manage. Block sites. Oh, I wanted you to ask first. Thank you. Now let me go back into it. Allow. Maybe I've asked you to use this one instead. Either way, you would do the same kind of thing. Let's have a look. Oh, I think one of the websites wasn't working for me, so I provided both links. Okay, wood. 13.3 grams. Okay. And now I'm going to put it in this one. Nope. What am I going to do? Drag it above the tank and drop it in the water. Why can't I drop it in the water? Oh, okay, and it's gone up to, I dropped it in the water, and it's gone up to, what, 15.1, 2, 3, 4, 5, 6, 15.6 milliliters. I'm gonna guess that it will float, because it's wood, frankly. Let's find, now its density would be 13.3 divided by 15.6. You have a calculator. 13.3 divided by 15.6. 0.85. 0.85 grams per milliliter. And let's actually see if it floated. Well, I'm going to guess that it will float. Let's watch. Yeah, it floated. Yeah, you're going to do that with this website. If this website doesn't work, use the one at the top of the thing. Oh, it's only for 5 minutes a day. That's why I put the second one in. Some things explain themselves. All right, have fun with this today. You're going to do that for all of those objects. You're going to find the mass. You're going to find the volume. You're going to guess whether they floated or sank. And then you're going to write down whether they floated or sank. And you're going to find their density. And we're going to discuss this later, but there's a certain density that, like if you're less than that density, you'll float. And if you're more than that density, you'll sink. And that density is the same density as water. So that's 1 gram per milliliter. So if your density is less than 1 gram per milliliter, you're going to float. And if it's more than 1 gram per milliliter, you're going to sink. Now I'm going to finish my breakfast. Have a good day.